Thank you for joining me here, and thank you very much for inviting me to do a talk today. So, as was mentioned, my name is Baird McIlwraith, and today I'll be discussing the transition and expansion of service offerings using Signals VitroVivo, or to give it a more kind of catchy, more memorable name, Modernizing Cancer Cell Screening. Before we launch straight into it, though, a little bit of background about myself. So, here's me on the bottom right, looking all smiley in Vienna, actually, where I was just before I started this job, just under 2 years ago now. So I work as part of Revvity in the Cambridge, UK area in the Platform Innovation Department as a laboratory informatics scientist. And as I said, I've been doing it for just less than 2 years, where I, day to day it's a very varied job. But do lots of different things, from configuring systems and LIMS systems in particularly, to getting into a bit kind of more of the bioinformatics, Python, and R side, because that's in the past that's where I did my master's by research as in bioinformatics at the University of Edinburgh. So it's just a little bit of everything, really. Outside of work, well, if you hadn't guessed, I'm Scottish, so in order to live up to all the stereotypes, obviously I have to have a kill. As you can see here at my graduation, where I've got a bit more hair than now. And I played a fiddle, obviously, but one for maybe American attendees as well is I actually play Quidditch and quadball, so which is a massive sport in America, actually. And outside of that, like apparently most people my age, I do rock climbing, and I've got some pets to keep me on my toes. But jumping into the talk now. So, as I said, the aim of this talk is transition and expansion of services, but in order to kind of give some context to that, we've got to go back and say, well, what do we have just now? What's the service we're wanting to expand, really? And that is our OncoSignature screening platform here in Cambridge, UK. So this platform screens around 300 cancer cell lines on a kind of rolling 4-month basis, where customers send in kind of their own compounds to test against these cell lines in either a single way or as a part of a combination. And we also use our own in-house kind of standard compounds for good comparisons. And the main way in which we determine, whether these agents work well against these cancerous cell lines is through cell titoglow, which is a luminescent ATP-based assay. This luminescence value is taken at initial seeding, so-called T0 or time zero, and then again at the end of the experiment, at the end of the treatment. So normally this is between 72 hours and 144 hours, normally post-seeding. And then we use this value to calculate, in the most part, a growth inhibition value, which essentially works out whether a cell line has been cytostatic or cytotoxic, so whether the cell stopped growing or it's actually been killed by either the one agent or a combination of agents. And then finally, we determine whether in a combination screen we have a synergistic effect, so that is, the agents have worked better in combination than they do on their own, or actually we've got an antagonistic effect where the agents have worked not as well as they would on their own. And this is really where we're going to focus on today. This is really the interesting part that we wanted to, in the first instance, replicate in VitroVivo. So we're transitioning now into VitroVivo, but again, before we do that, we do actually need to do a bit more of an investigation before we even get to VitroVivo at all. We need to kind of almost better understand our synergies. So I've explained the concept behind synergies, and it's this antagonism, the synergistic effect of when we have more than one agent, hopefully working together, in this case to kill the cancer cell lines. But we need to understand it in a much deeper level so that we can implement it in our custom software. So we found that there's many different algorithms there, and we need to kind of decide how do we calculate it. And we've got this overall kind of algorithm or calculation, which is observed minus expected. So observed in this case being our growth inhibition value. Our expected is one of these algorithms here. So we've got HSA, Bliss, and Loewe. These have been around, some of them, for almost 100 years now, whereas ZIP is very much kind of the new kid on the block, only came out a couple of years ago. But the main difference between these algorithms is that they assume different chemical assumptions, really. Loewe, for example, calculates the expected response based on the assumption of drugs acting in a dependent manner. So specifically, these combined effects are the same as if the drug was interacting with itself. Whereas Bliss assumes the opposite. Bliss assumes independence. So the answer to this question, which algorithm is the best? Well, there really isn't one. It's more for your assumptions that you would like to make. But whichever one you choose, that goes into this as the expected value in this calculation. For us, going forward, our current platform OncoSignature, it uses Loewe for the most part. It does offer HSA and Bliss, but as a standard offering, uses Loewe. So that's just the one we went forward with. So we've worked out, how synergies work. We've done a bit of digging about the algorithms, which we'd like to use and how they kind of fit together. But importantly, how do we actually implement these algorithms? In the past, they might have been hand-coded, but we want to do it in a more modern way, really. That's the kind of theme of this. And after a bit of digging, we come across an R package called Synergy Finder, which seems to do this for all of us. It seems to implement all four as a part of an open source R package. Great, solved, fixed. Well, not so fast, unfortunately. As with biology, there's always a sticking point. And so this is when we started to implement it, and we started to compare historical data from the current system against our newly calculated data using Synergy Finder. We find that, for example, in this case, this top drug the numbers aren't great, and the curve that's generated, well, let's be honest, it's not a curve; it's a straight line. And the synergy we get from this it's not great either. It's not a very useful set of synergies. And this is using ZIP, which was created more to answer the problem of high throughput, whereas we wanted to use Loewe, and at least in the first instance, we wanted to recreate the system we've already got using the algorithms we've already implemented. So for Loewe, we find that sigmoidal curves are an absolute must. And indeed, if we look at a previous experiment, so this is OncoSignature data, you can see here we have our points here, and we have a sigmoidal curve. One could argue that this is just noise, and maybe it is, but in order to generate meaningful synergies, we need a sigmoidal curve. As I say, that's the inherent problem with high throughput, is we can't kind of start cherry picking concentrations that will allow us to kind of pull out the sigmoidal curve. So after a lot of months, personally actually, I came up with a kind of curve fitting algorithm which does exactly this, which kind of forces a sigmoidal curve, which looks a bit like our existing platform. And because of that, we can start in Synergy Finder, which again implements all of these algorithms here. And crucially, it allows these custom curve fits as well, allows a custom curve fitting algorithm. And as you can see, we've managed to recreate some of our data. We've got some nice curves on the left. We've got our response matrix, so our growth inhibition values, for example. And then in this case, we're showing the ZIP synergy, but we can do Loewe, and we do use Loewe for that. So that was really the exciting bit, is that a combination of Synergy Finder and our own custom curve filtering algorithm allows us to recreate the data from the existing platform. But this is a talk about VitroVivo, and we want to obviously go further. We want to use VitroVivo to do this. And so the question is, can we use VitroVivo to recreate this, to actually use it to host all these moving parts? And I don't think I'd be sitting here giving you a talk if the answer wasn't, yeah, it can. So here's some curve fittings that we did within VitroVivo using the custom curve fitting algorithm. Can do those well. We've got some historical data being compared to our current experimental medians, for example. And we've got a lovely little synergy heat map, again, courtesy of VitroVivo. So VitroVivo can do it all, really. It's everything we need to recreate the system. It's got our visualizations, it's got user interactions in the form of drop-downs and buttons. It's got, crucially, custom scripts and calculated columns that, we can put our curve fitting algorithm, and spoilers for the future, we could probably put Synergy Finder in it as well. And it's also got a data ingesting outputting, so we can connect directly to our, in this case, Postgres backend data lake to pull our data in and send it back again if we'd like to do that. So really, Signals VitroVivo and Synergy Finder is great. We've managed to combine the two. We do use data functions within VitroVivo to run Synergy Finder on our data, start to end, pull our data in, do the response calculations, do the synergy calculations, and make lovely visualizations like this. And we did this within a standalone DXP file, which is hosted on Signals Notebook. And it means that anyone with access to this DXP file can just load up their data, see the existing data, and do these same calculations, which is great. We can use Signals Notebook as that central source. So that's great. So far we have actually managed to replicate our OncoSignature platform for the most part, at least the standard offering. But we want to go a bit further than that. We want to, as the title says, transition and expand. So we don't just want to kind of replicate, we want to actually improve. And the way in which we do this is by using the whole suite of VitroVivo apps, using all the functionality that they have. So this is both in terms of the built-in apps. So for example, along the top, some of the most common ones we use, data import app, editable data grid, but also within our custom apps. So that's customizing ones that are already out there, or even writing our own, possibly. And this gives us full flexibility to make it both modular and flexible. So we can swap the endpoints out, for example. So we have some endpoints, in this case, cell titleGlow being the main one. But for example, we also might want to offer HTRF or Caspase. So because it's a modular system, we can swap these apps out when required. And also in our case, we're no longer reliant on the standalone DXP file. We are, we can actually access it from the cloud. In our case, a software as a service, a SaaS environment. We don't have to even host the server ourselves, which is, very useful for us. And crucially, we can use the Signals Notebook as a kind of data repository for all our data, rather than kind of some separate database system that we have to manage. We can just use Signals Notebook, and the apps are designed to connect to the Signals Notebook. So if we're to envision this as more of a more modular, flexible workflow, then the first step, as you probably would have guessed, is to actually import the data from the Signals Notebook. So on the left here, we have some tables with our compounds and their concentrations in this plate here. And on the right, we have our raw data. So this is the luminescence of our Envision machine, our cell titleGlow readout. And so we can use some of these apps along the top. These are the built-in apps. We use the editable data grid to pull in our concentration data into VitroVivo. And then we can also use the grid plate editor to pull in our plate data into VitroVivo. So that's great. It's sitting there. It was as easy as that, very, very simple. We pull in that data, it's in VitroVivo, it's ready to go for further analysis. So now we get to, potentially the most, one of the more exciting bits. Obviously, it's very exciting, but, we're here for the more complex parts. So in this case, we're doing our response calculations. This is our growth inhibition calculations. This is where we might have different endpoints. This is where we're really leveraging the modularity of VitroVivo and those apps, is that we can create a calculations explorer based on our different endpoints here. So we've got subtactical HTRF, Caspase. Don't worry, these aren't the actual calculations we use. These are just some things I wrote down. And means we can swap them in and out in this modular system. And we can implement these either in terms of a calculated column, or if it's more complex, there's more moving parts, more data to pull in, you can do it in a custom R script in the Calculations Explorer. You can save custom R scripts to this Calculation Explorer to be recalled and reused at any time, which is really, really good for the end user. And then kind of tying all this together is not only can you write your own custom R scripts, we can also pull in external packages. So in this case, it's what we've been talking about. The Synergy Finder R package, we can pull it into a data function, write our script, write a really complex script if we want, and save it to the Calculations Explorer. So this can be pulled back by any scientist. You know, you don't have to sit there control entering your way through an entire R script, for example. You just load up this Calculations Explorer. As long as your data is in the right format, then it goes, it works. You calculate your synergies. It's great. We can also use their curve fitting app, for example. So we had to, in this case, we wrote our own curve fitting algorithm, which we built into the Calculations Explorer, but VitroVivo, it's got a nice curve fitting algorithm already sitting there for you. And as well as this, you can also save the visualizations to this Calculation Explorer. And all this is really key because, yes, we can save these as a workflow, but also you can use these apps in a standalone bit. Once you create that Calculation Explorer template, you can use that as long as your data fits the input shape. You can use it standalone or as part of, in this case, as part of a workflow. So that was the really exciting bit, is to be able to tie all of that together, to tie the investigation and this Calculations Explorer within the VitroVivo system all together. As I say, we can build our own Calculations Explorer app for this exact purpose. And then finally, you know, what good is creating some pretty data within VitroVivo if we can't publish it or post it anywhere? But again, we've got it covered. We've got our published measurements. This is for pushing to the Inventa system for further analysis. We can also easily export the raw data, the tables, the visualizations back into the notebook. So we have our full round trip. We've got our raw data, bring it into VitroVivo, analysis, swap our apps in depending on their endpoint, and push it back into the notebook. So if we take this all together, we've essentially pieced together all these kind of apps, both custom and built-in, into our own nice little workflow, really. In this case, I built one for doing cell title with synergies, you know, catchily named Analyze Cell Title 2 with synergies, but, you know, naming's never really been my forte. But we've pulled all these apps together, and then you can break it up, you can swap bits in and out. It's really good and flexible. It's a great system rather than having to redo your entire workflow every time. And so this really takes us on to the key takeaways. What I'd really like you to get from this talk is this combination of Signals VitroVivo and Synergy Finder, for example. But Signals VitroVivo really is a way to host all of our calculations and needs. And so we started from our OncoSignature platform, where we have the cell title glow readouts. We have kind of a very standard offering, but one which doesn't necessarily have the modularity and the flexibility that we might want going forward. So instead, we've taken Signals VitroVivo, we've taken Synergy Finder, and built this flexible modular system on VitroVivo using our Calculation Explorer templates to save all of our calculations, our different endpoints, our different, you know, we can swap in and out the third Calculations Explorer to do different synergy algorithms, for example. We can swap one for Bliss, we can swap one for Zip if we're feeling particularly adventurous. That's just what I've said, you know, swapping our endpoint, for example, HTRF instead of cell title glow, that sort of system. And we integrate these Synergy Finder calculations so they're much, much easier to use, both standalone and as part of a whole system. So all that's left for me to do is thank people. So my manager here, Revvity at Cambridge UK, David McIlwraith, as well as the rest of the screening team, who have been absolutely amazing, especially in the initial investigation phase, where I was always asking for, give me some pretty pictures, give me some more data, help me understand these algorithms a bit more. So they've been really, really useful. I'd also like to thank some of our colleagues, especially within Signals VitroVivo and the Signals Notebook, for helping us set up the Signals Notebook, spending hours talking us through it, and get set up with the VitroVivo in the SaaS version and showing us just exactly what we can do with the system. And I'd also like to thank the rest of the Revvity NEXUS 23 team for putting on such a great event. And hopefully I'll see you later in the Q&A. Thank you.